This lesson is on energy. Energy is a very important topic to the rest of the year in physics. Everything that we do is going to be related to energy, so it's really important that we understand. The definition of energy is the ability to do work. So you have energy if you have the ability to do work. So since you, as a person, a living thing, have the ability to do work, you must have energy somehow. We're going to study two specific kinds of energy. The first being kinetic energy, which is simply energy through motion. Remember, the prefix kine means motion. And potential energy, which means energy through position. Kinetic energy we're going to symbolize with a capital K. Potential energy we're going to symbolize with a capital U. Whenever you do work on something, do work on an object, its energy changes by that same amount, which means that work equals the change in energy. This is often referred to as the work energy theorem. So we can write it like W equals delta K if we're doing work to change kinetic energy, or W equals delta U if we're doing work to change the potential energy. When work is positive, objects gain energy. When work is negative, objects lose energy. Positive work means you're speeding up or gaining position. Negative work means you're slowing down or losing position. The equation for kinetic energy, K equals 1/2 mv squared. Remember that energy is measured in joules. Since energy is related to work, they would have to be measured in the same unit. So an example from page 6 of your packet, question number 10. We have a car that's initially going 55 meters per second, and then it speeds up to 85 meters per second, and we're supposed to figure out how much work is done. Well, the first thing that we would do is figure out the kinetic energy of the car before and after it speeds up. So using the 1/2 mv squared equation, my car starts out with this much kinetic energy. You can write it like that, or you can write it in scientific notation, whatever. The kinetic energy the car ends with, do the same thing, only plug in your new velocity, would be this amount, 2.89 times 10 to the 6 joules. So I start with 1.21 times 10 to the 6 joules, I end with 2.89 times 10 to the 6 joules. Work is the change in energy. Remember, that means final minus initial. So if I just subtract the final from minus the initial, that gives me the change in kinetic energy, which is the work done. We know that the work done is positive, our answer should be positive, because the car is speeding up. So since it's gaining energy, it makes sense we get a positive answer for the work. If I wanted to slow the car back down to 55 meters per second, I would simply do negative 1.68 times 10 to the 6 joules in order to make it slow down. Potential energy, which we're going to symbolize with a capital U, is energy through position. And there's several different ways that you could have energy through position. Sometimes potential energy is referred to as stored energy, because you can put something in a certain position and have it stay there, and you can keep it there for a long time, so it has energy for a long time. So a good example, say you have a rock hanging above your head. That rock could fall, hit you in the head, and it would do work on your head, knock your glasses off or your hat, possibly even worse. So the rock has energy. It has energy through position because it's hanging above your head. That kind of potential energy would be referred to as gravitational potential energy, which was symbolized with the U subscript G. In that case, the position is the height. To figure out gravitational potential energy, we're going to use the equation UG equals mgh. M is mass, G is gravity, 10 meters per second squared, H is the height in meters. Another form of potential energy is electric potential energy. That's the energy between charges. Batteries store electrical potential energy. We'll discuss more about that later on this year. The third would be chemical potential energy. energy stored in chemical bonds. You learned about that last year in chemistry. You get all your energy from chemical potential energy from your food, carbohydrates and sugars and fat and protein and those sorts of things. A fourth kind of potential energy is elastic potential energy. That would be like stretching a spring or a rubber band. So when you jump on a trampoline, you're taking advantage of elastic potential energy to push you up higher and higher and higher. So a good example is on page 8 in your assignment packet. So in this example, a plane starts at a height of 15,000 meters and it dives down to 11,000 meters. And you're supposed to figure out the change in gravitational potential energy. Remember, that equals the work. So we know that potential energy is mgh. So real easy, we can find the change in potential energy by doing mg delta h. The mass doesn't change, g doesn't change, so delta h is the only thing in there that's changing. So plug in our numbers. Remember, final minus initial, so it's 11,000 minus 15,000 for your change in height. And you would get delta UG equals negative 3.4 times 10 to the 6 joules. So this airplane is losing potential energy. Later on, we'll talk about where that energy actually goes and how you can get it back and how it makes the plane go faster and things like that. Again, the work is negative because the plane is losing energy. So when you lose energy, then the work done is negative. Hopefully this video lesson has been helpful to you. As always, if you have any questions, please let me know and we'll try to clear it up during tutorials. Thank you.